Now let's try example 4, question number 3. Referring to the figure below, a cone has a circular base with radius r and the height of the cone is h. Given that the length of AB is 3 cm, find the value of h if the volume of the cone is to be maximum. Hence, state the maximum volume. So now we want to determine the value of h so that the cone has the maximum volume. So we take v as our function, which is the volume of the cone. The formula for v is v equals pi r squared h. So in order to find the maximum volume, we have to differentiate v with respect to h. But in this case, it is not possible yet because we also have r in the equation. So in order to differentiate v with respect to h, we need to express r squared in terms of h. From the diagram, we can see that there is a right angle triangle here. So this right angle triangle can be represented in Pythagoras theorem, which is 3 squared is equal to h squared plus r squared. So since we want to express r squared in terms of h, so r squared is equal to 9 minus h squared. And then we substitute r squared into v. We get v is equal to 1 over 3 pi times 9 minus h squared times h. And then we expand that, we get 1 over 3 pi times 9h minus h cubed, and finally v is equal to 3 pi h minus pi over 3 h cubed. Then we are going to need to find the first derivative of v with respect to h so that we can solve it and then find the values of h when the first derivative is equal to 0. So at maximum volume, dv dh is equal to 0. So we need to find dv dh first. So dv dh is equal to 3 pi minus pi h squared. And when dv dh is equal to 0, 3 pi minus pi h squared is equal to 0, then pi h squared is equal to 3 pi, so h squared is equal to 3, so h is equal to 3. Note that we only take positive value here, since h is the height. So h is equal to the square root of 3. And then we need to find the second derivative to verify whether it is maximum or minimum. So we have the second derivative of v with respect to h is equal to negative 2 pi h. So when h is equal to the square root of 3, the second derivative is equal to negative 2 pi square root of 3. Alright, so negative 2 pi square root of 3, if we rearrange that, we get negative 2 times square root of 3 pi is actually less than 0. Therefore, the conclusion is it is a maximum. So now we can already conclude that when the volume is maximum, h is equal to square root of 3 centimeter. And then we need to find that maximum volume using the value of h that we already obtained. So V maximum is equal to, using the formula for V, which is 3 pi h is equal minus pi over 3 h cubed. So when h is equal to square root of 3, V maximum is equal to 3 pi times square root of 3 minus pi over 3 times square root of 3 to the power of 3, which finally gives us 10.883 centimeter cube. So this is the maximum volume.